Hi guys, we're going to be going over the plant association lab analysis today. In the field this week, we all went out to Pocohantas State Park and looked at a couple understory species. We want to determine if there is an association with the overstory and the understory species. The understory species that we're looking at this week were Echemophila maculata and Epiphagus virginiana. So we have the null and alternative hypotheses right here. They can be a variation of the wording of this. Basically, the null is saying that there's not an association between the understory and the overstory, and the alternative is going to state that there is an association. So in the field, we went out at the state park and we looked for Chemophila and Epiphagus and recorded the observations and what tree they were closest to. These values that we went out and determined are going to serve as your observed values for the chi-square test, right here in red. And the relative density was independently determined using the point quarter sampling method. And we can use the relative density and the total number of occurrences of each understory species to determine the expected values that we can use for a chi-square test. Right here, you can see the formula for the expected value is the relative density times total understory occurrence. So this column multiplied by this column for each species independently. So we can make a table with for each of the understory species, and the headings will be observed, expected, observed minus expected, and the partial chi-square, which is equal to observed minus expected, which is squared divided by the expected. Then we sum up the entire column, and that will give us our chi-square value. Now you can do your chi-square by hand, but we're gonna have to put all of these values in exactly like this for your appendix. So I'd recommend doing it in Excel. I showed you in the last video with the salamander data that I did it by hand to show you how to do that. But make sure when we're doing this, we make sure that each formula is correct. So after you've got your columns, your headings in your table, we can start to calculate our chi-square value. So the first thing we're going to do is we're going to copy the observed values from the data. And we're going to sum all of those up. And then the expected values, like I said before, the formula is going to be the relative density times the total number of observations for each understory species. So for Chemophila, and for the first one, which is red maple, we only saw one occurrence and the relative density was 0.08. So calculating the expected is going to look like this. You're going to have the relative density multiplied by the total occurrences of Chemophila. One more time for pignut hickory, we're going to multiply the relative density by total observations. And we're just going to keep doing that for every single one of the species. What you can do also to help is take this column and also copy it over. It's just so my eyes can't follow these lines. So just to make sure you're continuous with your raw data. American holly, relative density times the total column. So what I just did there was drag this formula down and I didn't copy it correctly. So I'm just, what you can do is drag it down and they're all zeros. So that should be a warning to you that's not right, but it has the formula right here. So it's multiplying E10 by C21. So you can go through and see E10 is the right relative density, but we're multiplying it by C21, which is just an empty cell. So you can just go through all your values and correct this to C20. I always go through and double check, make sure the other values are copied correctly as well. I honestly check it like 4 times just to make sure, because it's a pain to correct it later. But after I do these last couple, we want to sum the column, and we're going to move on to the observed minus expected. These two values should be the same. So just as it looks like, you subtract the expected from the observed value. And we're going to take the positive values of all of these. Sorry, we're going to leave these values alone. Just sum this column. And then we're going to go and do the partial chi-square, which I have right here listed the formula that you can use if you want to go through and you add the equal sign and then paste that and then insert each value. So you get your observed minus expected squared divided by expected. Oops. I did that wrong. It's H5. And if we copy it, you can check that it's the same row being copied. So they're both 6. And go through and look at the top. They're all the same number. Okay. So after you've done that for all your partial chi-squares for each of the overstory species, you can sum this up. And this is your chi-square value. So in general, I just don't like having more than 2 decimal places. When you're doing calculations, Excel still knows that there's more decimal places, and when you do your calculations, you'll still have the right rounding, but it just looks neater. So you're going to do all of this again for the second understory species at Vegas, and you're going to get another chi-square value, and we're going to compare that to the critical value. So if you come down here, we're going to look at table 1B3 from the Brower-Sar handout. You have the chi-square table of critical values. We're using alpha equals 0.05. And to calculate the degrees of freedom, you're going to subtract 1 from the number of rows or the number of overstory species. So here, there's 15 rows. 15 minus 1 is 14, so that's our degrees of freedom. At alpha equals 0.05 and degrees of freedom at 14, our critical value is going to be 23.685. So I have that written down right there. And this is the value that you're going to be comparing your chi-square value to. If your chi-square value is greater than the critical value, you're going to reject the null. If your chi-square value is less than the critical value, you're going to fail to reject the null. We're going to come up here and look at our critical value, or sorry, our chi-square value, and it's 57.02, which is greater than 23.685. So we're going to reject the null hypothesis, which we're going to go back up here and look at again, that the understory species are not associated with the surrounding overstory species. We're going to reject this and accept that there is an association with the understory species. So it's great. Now you've got that, you know that there is an association or is not an association. And when you're writing your report, you're going to locate which overstory species has associations with each understory species. Where there is an occurrence and where there is not an occurrence is all data. So if there was not an occurrence, that could also mean something. We're trying to determine what type of association is happening here. For example, is it a positive or negative association, or is it random? Your literature review will help you determine if any of these species have any associations with them. Let me see what else I have to say. You also can use relative density, as we did in the point quarter sampling last week. We saw that we can use the relative density to help determine what the structure of the forest looks like. In this data set, we had white oak as the dominant species. So look at those with occurrences of each understory species to help determine what the relationship is. That is all I have for today for the Plant Association Lab. If you have any questions, feel free to email me or ask on Discord. Otherwise, good luck with your writing.